We say that we have simultaneous equations when we have two or more equations involving the same unknown quantities. In our example, we have two different equations in x and y. Let's call them 1 and 2. We need to use these equations to find values of x and y that satisfy both at the same time, or simultaneously. If we look at equation 1 on its own, there are many possibilities for x and y. We could take x as equal to 2 and y as equal to 6, or x is equal to 6 and y is equal to 4. Both of these would provide a solution to equation 1. What about equation 2? Well, we could take x as equal to 3 and y is equal to 8, or we could have x is equal to 5 and y is equal to 2. Again, these values, one for x and one for y, provide a solution to equation 2. But of the four pairs of values that we've written down, none provide a solution for both equation 1 and equation 2. There are several methods to solve simultaneous linear equations. One common way is the elimination method. In this method, we try to eliminate either x or y from the equations. The first thing to do is rewrite both our equations. X plus 2y is equal to 14, and 3x plus y equals 17. The idea of elimination is to somehow generate the same number of either x's or y's in both equations. In this instance, we're going to focus on getting the same number of y's. How can we do that? Well, we could multiply everything in equation 2 by 2. This gives us 6x plus 2y equals 34. Equation 1 remains unchanged. We can see that the y term in both equations is the same. Now we subtract the bottom equation from the top to give us negative 5x plus 0 times y is equal to minus 20. We can discount 0y as that's 0, which leaves us with negative 5x equals negative 20. What number multiplied by minus 5 gives us minus 20? Well, that's 4, so we can say that x equals 4. We can now substitute this value, x equals 4, into our original equations. So for equation 1, we have 4 plus 2y equals 14. We know that 2y must be equal to 10. What number multiplied by 2 gives us 10? That's 5, so we can say that y is equal to 5. We can check this value by substituting our value for x into equation 2. That gives us 3 times 4 plus y equals 17. 3 multiplied by 4 is 12, so we have 12 plus y, which means that y must be 5, the same answer we got for equation 1. So the values that solve both equations are x equals 4 and y equals 5. Now let's look at another common way to solve simultaneous linear equations, the substitution method. Equation 1 says that x plus 2y is equal to 14. We can rearrange this to isolate x by subtracting 2y from both sides. And this gives us x equals 14 minus 2y. We can now substitute this expression into our second equation. This gives us 3 times by 14 minus 2y plus y equals 17. This leaves us with an equation with no x terms, so we should be able to solve it for y. First, we need to expand the brackets. 3 multiplied by 14 gives us 42, and 3 multiplied by minus 2y gives us minus 6y. So that's 42 minus 6y plus y is equal to 17. We have two like terms on the left, minus 6y and plus y. If we perform the calculation, this gives us minus 5y. And we can isolate the y term by subtracting 42 from both sides. And this leaves us with minus 5y is equal to minus 25. What number multiplied by minus 5 gives us minus 25? Well, that's 5, so y is equal to 5. We can now substitute this value into our first equation. This gives us x plus 2 times 5 is equal to 14. Perform the calculation in the brackets and we get x plus 10 is equal to 14, so x must be equal to 4. We can check by substituting y into our second equation. So we have 3x plus 5 equals 17. What number multiplied by 3 gives us 12? That's 4, so we can be confident that x is equal to 4.
As if that win